all of you to the next session of Exploring Physics. We are studying the second lesson called Physical Quantities and Measurement, right? In the last class, we learned to determine the density of an irregular object. We learned to measure the mass using the physical balance and spring balance. And we also learned to determine the volume of an irregular object using water displacement method and Eureka can, right? I think you all remember those topics. In the last class, we saw an activity, right? We poured 3 different liquids into the glass. One is syrup, another is water, and the next is oil. When we poured these 3 different liquids, they didn't mix, but they formed 3 different layers. Why? Because they have different densities. Okay, now tell me, will you be able to determine the density of these liquids? Okay, we are going to learn that. What are we going to learn today? Can anyone tell? We are going to determine the density of liquids. Exactly. Good. Can anyone tell the formula of density? Exactly. Density is defined as the mass per unit volume, right? If you want to determine the density of liquids, you should be able to measure the mass of liquids and you should be able to determine the volume of the liquid. Then we can substitute those things in this formula to get our density, right? Okay. What can be used to find the volume of liquids? Do you remember? We have studied in our 7th standard. Very good. Measuring cup and measuring cylinders can be used to measure the volume of liquids. Can you see the graduations in the measuring cups and measuring cylinders? They can be used to measure the liquids accurately. But let's say I want you to give me 15 milliliter of water exactly with the maximum accuracy. Okay? Will you be able to do that with this help of measuring cup and measuring cylinder? You will be able to do, but there will be some lack of accuracy due to the human error. It can be due to the vision error. Okay, there will be some lack of accuracy when we are doing with these things. So what can we use to do that? Yes, we can use the instrument called pipette. This is the kind of pipette which we are using in our school laboratories. If you have visited the school laboratory, definitely you would have witnessed these kind of pipettes. Pipettes are used to draw the liquid and it can be used to transfer the liquid into another beaker or measuring cup, cylinders. Okay, so let us see how to determine the density of liquids using these pipettes. First, we have to take one measuring cylinder and weigh it using some balance. Then we have to draw the 15 milliliter of liquid using the pipette. Then that pipetted liquid should be transferred into the measuring cylinder. Okay, that's the second step. After that step, we have to weigh the measuring cylinder. The measuring cylinder with the liquid should be weighed. The difference between the two masses gives the mass of the liquid. That is, mass of the liquid is equal to mass of the cylinder with the liquid minus mass of the cylinder. So can you get this? Mass of the cylinder with the liquid minus mass of the cylinder. This can give us the mass of the liquid, right? So we now have the mass of the liquid and volume of the liquid. We can easily determine the density of liquid by substituting, right? So this is how we determine the density of liquid with the help of the pipette. These are the points which we saw previously. Take down these points. So we know what is density. Can anyone tell what is relative density? Exactly. Relative density is comparing the densities of different substances with that of a standard substance. Read it again. Comparing the densities of different substances with that of a standard substance. What is the standard substance here? Water is the standard substance here. So we know what is relative density. How will you find the relative density of a liquid? For that you have to know the formula, right? Relative density is defined as the ratio between the density of the substance and the density of the water. Okay, this is very important formula. You will use it in your problems. In many areas you will face this formula. Okay, so remember it. Water is the standard substance. Okay, so relative density is the ratio between the density of the substance and the density of the water. So now there's a question for you. How will you find the relative density of ice? For that you have to know the density of ice, right? So this is the formula. Density of ice is 916 kilogram per meter cube. Density of water is 1000 kilogram per meter cube. So we have to substitute it and we are getting 0.916. Right? What do we infer when we say the relative density of ice is 0.916? Okay, you have to note that the relative density has no unit, right? Because the units get cancelled each other. Okay. What do we infer when we say the relative density of ice is 0.916? It means density of ice is 0.916 times density of water. So what is the purpose of finding the relative density? It helps us to compare the density of one substance with the density of another substance. Here we compare the density of ice with the density of water. We say that the density of ice is 0.916 times the density of water. Okay. If we take same volume of substance, it's enough to find the ratio between the masses. That is, we have to take same volume of water and as well as same volume of ice. Okay, let us see how. Let us denote the volume as V. Mass of substance of volume V is equal to M1. Mass of water of volume V is equal to M2. That is, we have taken the same volume. We have denoted that as V. Relative density, we know the formula. Density of a substance divided by density of water. Now, we are going to substitute M1 by V divided by M2 by V. What will happen? The volume and volume will get cancelled and we will get M1 divided by M2. So, We can also define the relative density as ratio between mass of the substance and the mass of the standard substance, right? We have two kind of formulas for the relative density. If you have given the density in your hand, you can find the relative density. If you have given the mass of any volume of substance and mass of same volume of water, you can find the relative density. So what do you think if we have some tool to measure the standard volume of substance, or to take up standard volume of substance, it will be very easy for us to calculate density and relative density, right? We use pipette, right? But while using the pipette, we should have the skill of using pipette, or else you will go wrong in calculations and measuring. So is there any other instrument which we can use to determine the density and relative density easily? Yes, there is this instrument called specific gravity bottle. Specific gravity bottles are available in fixed capacities. Can you see the capacity being marked? Yes, the capacity is marked on the outer surface of the wall of the bottle. The bottle has glass stopper with a thin hole. When the bottle is filled with the liquid, the stopper is pushed in. Some liquid flows out of the hole. The volume of the liquid that remains in the bottle is exactly equal to the volume marked on the bottle. So, how should be the specific bottles used? We have seen in the previous slide, right? So, take note of these important points. Yes, definitely. We shall watch a demonstration video to learn about specific gravity bottle, because it will be very easy to understand the usage of specific gravity bottle, right? So let us watch. So this is the empty specific gravity bottle. Make sure that the bottle is clean. Okay, then only the measurement will be right. The empty bottle with the stopper should be weighed. Okay, yes, they are weighing, right? Let this mass be M1. Then fill the bottle with the liquid and insert the stopper gently. Dry the bottle with the blotting paper to get rid of the spilled liquid on outer surface. Then wait again. Let it be M2. The difference between the masses will give us the mass of the liquid, right? So we have easily found out the mass of the liquid. Then how can we calculate the density? Let us see. The mass of the liquid is equal to M2 minus M1. The volume of the liquid is equal to V. Then the density of the liquid is equal to M2 minus M1 divided by V. So this is how we find the density of the liquid using the specific gravity bottles. We will learn some important vocabularies to move to our next topic. Shall we? Here a cartoon character is riding the boat, right? How do we say that? The boat is floating on the water, right? What is the meaning of floating? A body is said to float when it stays on the surface of the liquid, right? Here, the boat is staying on the surface of the liquid, so we say it is floating on the water. A boy is throwing a stone into the river. What will happen? The stone will go to the bottom of the river. We say it is sinking. A body is said to sink when it goes to the bottom of the liquid. Shall we watch an activity video to start our next topic? Yes. So it will refresh our mind, right? in this activity, we have dropped many things into the water and we analyzed whether it is floating on the water or sinking into the water. If you have noticed, you could have observed that things like paper clips, crayon, tie car, etc., they sink into the water. Why? Because their density is greater than that of water. But when you put lemon, orange, plastic ball, cork into the water, they float on the water. Why? Because their density is lesser than the water. That's why they float on the water. So we have witnessed the role of the density in our daily life, right? We should be very curious to observe our surrounding. We should observe these things around us. Okay, then only we can enjoy the science around us. In today's class, what we are going to study, why certain objects sink or why certain objects float. We are going to analyze that. So the topic is floating and sinking. What are the factors which makes the object to float or sink? Density, right? Density is the deciding factor which makes the object to float or sink into the water. But there are two factors. The density of the object and the density of the liquid under consideration. Both of the substance decide whether the object will float or sink into the water. So we will see some other activities to prove that. Let us take the cotton and drop into the water. What happens? Initially, it will float on the water. After some time, it starts to sink into the water. Why? Because after some time, the cotton gets soaked in water and it becomes denser. When it becomes denser, it sinks into the water. Okay, now let us take a balloon, empty balloon, and let's drop into the bowl of water. What will happen? Will it float or sink? It will sink into the water, right? Why? Because density of rubber is greater than water, so it will sink into the water. Now let's blow the balloon with the air and drop into the bowl of water. What will happen? Will it float or sink? It will float on the water, right? Why does the air-filled balloon float on water, whereas the empty balloon sink into the water? The air inside the balloon makes it lighter, so it floats on water. But the empty balloon is denser, so it sinks into the water, right? So if I will be playing a demonstration video, you have to observe that and you have to reason out your observation. Let us watch the demonstration video. So we have taken 2 lemon and 2 glasses of water. Let's see what we are doing.
Then drop the lemons into.
We have taken the lemon and the 2 glasses of water. The lemon is being dropped into the water. The lemon sinks into the water. The salt is added to the glass of water. More and more salt is being added. What are you observing? Can you observe anything? The lemon is rising up, right? Rising up. When the salt is added, the lemon starts to float, right? The lemon sinks into the fresh water, but when the salt is being added, it starts to float. Why? Can you find out the answer? Why does the lemon float on salt water? Salt made the water much denser. That's why it floats on salt water. Fresh water is less denser than salt water, so lemon sinks into the fresh water. Whereas the lemon floats on salt water. Why? Because it is denser than the fresh water. So these are the important points for you to take. These are the things we have seen in the last slides. So take down these points. The topics we have covered are measuring the density with the help of pipette. We studied what is relative density. We learned to measure the density using specific gravity bottles. And we also learned why certain objects float and why certain objects sink. So in the next class, we will learn how the ships are floating. So many interesting concepts are coming in the next class. The assignment question for this week are, these are the assignment question, okay? There are 5 questions. Don't think like they are very difficult ones. They are very easy question and answers. Okay, define the term relative density of a substance, calculate the relative density of ice. The next one is a problem. The mass of empty gravity bottle of volume 45 cubic centimeter is 30 gram. The mass of gravity bottle with the liquid is 75 gram. Find the density of the liquid. Which of the following will sink or float on water? So you have to find out which one will sink and which one will float on water. Cork floats on water, whereas iron nail sinks into the water. Reason out. So these are really easy questions. Do submit it in the Google Classroom. I expect more submission in this week. Thank you, students. Take care of yourself. Stay healthy. I will see you in the next class.